Well, of course, we would be able to do that because result has been defined in the closure's parent scope. So let's go ahead and take a look at how this works. We'll create another closure here called print result, and we'll set this equal to variables defined. We have the add. So if anything else that's very interesting, I32. All right, so that's really nice to be able to infer as I32 because Rust knows that our closure is returning an I32. All right, so that's really nice to be able to do multi-line closures. So let's say has inferred that we are returning a 32-bit signed integer. We're not actually using that value anywhere back in the parent function test closures. So let's say let result equal the result of the add function. And once again, you can see that this result variable is being inferred as I32 because Rust knows that our closure is returning an I32. All right, so that's really nice to be able to do multi-line functions here with closures, but there's something else that's very interesting about closures, which is that they actually inherit the variables that are defined in their parent scope. So if we take a look at our test closures function right here, we can see if we just look for the let keyword here, we have two different variables defined. We have the add variable, and then we also have the result variable. So let's say that we wanted to take this result and do something with it inside of a different closure. Well, of course, we would be able to do that because result has been defined in the closure's parent scope. So let's go ahead and take a look at how this works. We'll create another closure here called print result, and we'll set this equal to a couple of pipe characters for our input arguments. I'm not going to use any input arguments here, but I'm just going to say print line, and we'll say the result is, we'll put a couple of curly braces there, and then we're just going to directly pass in the result variable. And this is totally valid. So even though the closure here itself doesn't declare the result variable is bound to the closure simply because it was declared in the parent block of where the closure itself was declared. Declared. So if we were to actually execute this closure right here called print results, then we should see that the result is 8. Of course, our inputs to the add function were 3 and 5. The result got assigned to the result variable, which is an I32, and then we directly grabbed that result from the parent scope without even having to declare any input arguments. And you can mix and match that as well. So we could define input arguments, and we could then use those input arguments in conjunction with the variables that were inherited by the closure from the parent scope, right? So if we just said, x is an I32, then we could do something like the result is result plus x, and then we could pass in a number like 93 or something. And then if we run this, you can see that we get the result of 8 from the first execution of the add closure here, and then that gets assigned to result. Then we do result plus 93, so 8 plus 93 is 101. So it's really interesting because you don't have to declare input arguments. You can access those variables directly from the parent scope, but in some cases, you will want to be explicit and declare those input arguments here. So just be aware of that inheritance with closures. Now, I think the last topic that I wanted to cover for now, as far as closures go, is how you can mutate objects inside of closures. So if we take a look at this example right here with the print results closure, you can see that I accessed this result variable that we declared right up here as a result from the add function, right? We took that I32 out of the add closure, assigned it to this result variable, which is an I32, and then we just access it. We read that value inside of the closure called print result. However, we're not mutating the value of anything in here, right? From the parent scope, all we're doing is we're going to the parent scope, we're reading the value, and that's all that's happening. But what if we want to borrow this value and then mutate it inside of the closure itself? Well, how can we accomplish that? You might think, well, we could just do, let's make result mutable, right? Well, we're actually going to take a look at a different example here of how this works. And it's going to be a little bit bizarre, but once you understand how it works, hopefully it'll stick in your mind and then you'll be able to use this technique in the future. So in this particular example, I'm going to create a custom struct, and I realize that we haven't covered custom structs yet, but don't worry too much about it. I'm going to cover them in a future video, but I'm just going to define a struct called person here. And the person struct is going to have two different properties. It's going to have a first name property of type capital string, and then we'll do last name of type capital string as well. And then we're going to instantiate a new person, set the first name and last name values, we'll initialize those, but then we're going to use a closure to actually mutate that person struct instance inside of the closure rather than inside of the function where the struct instance was instantiated. So right down here in our test closures function, we'll just say let p1 equal, we'll do person, say first name is Trevor, and then we'll do last name is Sullivan, put a semicolon there at the end. And the reason we're getting these red squigglies is because we need to take that and call toString to turn it from a static string into a string that's allocated on the heap. And then we also need to call toString here as well. That's the capital S string type, not the pointer to a static string. So now we've got this p1 variable declared, and we want to build a closure that changes either the first name or the last name or both, doesn't really matter. And we want to mutate this object, but we want to mutate the object that's in the parent scope, not defined or declared and initialized in the closure scope. So let's do a new closure. I'll call it change name, and we're going to set this equal to a couple of pipe characters, or the last name, or both, doesn't really matter. And we want to mutate this object, but we want to mutate the object that's in the parent scope, not defined or declared and initialized in the closure scope. So let's do a new closure. I'll call it change name, and we're going to set this equal to a couple of pipe characters, put a semicolon at the end, and then we need to specify what we're going to mutate here. So let's do p1 dot, and then we'll say last name equals Jones. And then we'll do Jones dot toString because the data type of first name and last name is a capital S string. So we'll go ahead and save that. And we get one warning here saying that our change name variable is never accessed because we're not actually calling this new closure that we created. But take a look at what's happening right here. We are actually getting a compiler error here because it says that p1 dot last name is not declared as mutable. So you might be thinking, well, I'm just going to come up to the line where we declare and initialize the p1 variable and say let mute. That should take care of it, right? Well, let's give it a try and see what we get. If we do a cargo run, let's actually print out the value as well. So we'll say print line and say, let's just do actually a curly brace and then p1 dot last name so we can actually see what the last name is. Is it the original or is it the new value, right? So as you can see right here, the result is still Sullivan. It hasn't actually been changed to Jones, and that's because we never actually called the function. So let's go ahead and right before that, we'll say change name. And we don't take any input arguments here, but this is the error that I was actually expecting to receive right here. See how we get this error that says cannot borrow change name as mutable, as it is not declared mutable. So this is actually referring to the closure itself. It's not necessarily referring to p1 because p1 has been declared as mutable in the scope where it's declared. And when we try to access a mutable variable and actually modify the value of that mutable variable, we have to also declare the mute keyword on the closure itself. So this is very of that as, and it hasn't actually, right? So you might be thinking, well, I'm just going to come up to the line where we declare and initialize the p1 variable and say let mute. That should take care of it, right? Well, let's give it a try and see what we get. If we do a cargo run, let's actually print out the value as well. So we'll say print line and say, let's just do actually a curly brace and then p1 dot last name, so we can actually see what the last name is. Is it the original or is it the new value, right? So as you can see right here, the result is still Sullivan. It hasn't actually been changed to Jones, and that's because we never actually called the function. So let's go ahead and right before that, we'll say change name as mutable, as it is not declared mutable. So this is actually referring to the closure itself. It's not necessarily referring to P1 because P1 has been declared as mutable in the scope where it's declared. And when we try to access a mutable variable and actually modify the value of that mutable variable, we have to also declare the mute keyword on the closure itself. So this is very different from when we were just reading a value from the parent scope like this right here, where we do print result and we access the object right here, which is of type person, the person struct. We're mutating the last name field of that struct, and therefore we have to mark the closure as mutable as well. So now let's go ahead and do another cargo run, and now you can see that the closure has successfully modified the object that was declared and initialized in the parent scope, P1 of type person, right? So this is something that you really need to understand is not only does the variable itself need to be marked as mutable, but the closure that's actually doing the object mutation also must be marked as mutable. And then something that might be useful here, rather than just taking a hard-coded value here, we could actually declare that as maybe input that we could then pass in from the function call. So we could say new last name, for example, and we'll mark it as a string pointer, and then we could pass in Jonesy or something like that. Or Jonesy, maybe something like that. I don't know. But then we'll set this to new last name instead of just hard coding Jones there. And if we run this again, now we have Jonesy, which is being passed in as an input argument. Great. So we're just kind of building on top of our understanding of closures here, but there's another thing that I want to show you here. The whole concept of borrowing that we just discussed, where this closure is borrowing access to P1 so that the closure itself can mutate it. This borrowing actually happens as long as the compiler knows that we are going to be accessing this variable from inside the closure. So let's just kind of step through what's happening here. First, we instantiate the person. We initialize that value. Next, we declare the closure, but we don't call it. Next, we call the closure, and then we print out the last name. But watch what happens. Let's say that we duplicate this line where we invoke the closure, and let's change it to a different name, like maybe O. Sullivan, okay? Guess what happens? Well, once again, we get this error message that says cannot borrow P1.last name as immutable because it's still borrowed, right? So again, what's happening here, just like earlier, the compiler is actually looking ahead at our code, and it can see that we are borrowing P1 not just once, but actually twice here. So each time that we call change name, we still need to have P1 borrowed so that the closure has permission to update that field in our person struct. So therefore, we will not be able to access P1 last name until after we have completely finished accessing P1.last name from our closure. So after we call change name 2 different times, then we can go ahead and start to read that value again from the parent scope. And sure enough, you can see we change it to Jonesy, we change it to O'Sullivan, and so the final result is O'Sullivan. So anyway, I think that's pretty much everything that I wanted to cover in this video about closures. I know they can be a little bit confusing. The syntax is a little bit weird. It's a little bit bizarre when you get into things like mutable values that you're using inside of a closure. But once you kind of play around with things hands-on, I always encourage people spend hands-on time with Rust. Don't just watch this video. Go ahead and implement these concepts in your own program. Don't just copy the code I have here. Come up with your own concepts. Come up with your own examples. Maybe use temperature data as an example, like a weather forecasting app, or maybe an employee database type of application. Just come up with some other kind of example where you can use these concepts, but customize it enough that you're actually understanding these concepts rather than just copying what you see right here on the screen.
Good. So again, welcome from my side. Now the community news is over and we are going to focus on the next session, and it will be all about closures. Okay. So my talk is based on a column that I wrote for HiCTE. It came out a few days ago, I think on Wednesday last week. So I will take the material from this blog post as the basis for my talk. If you are interested in reading the entire talk, it's in German. Then I can share the link in the comment section or put it on Discord. I will do both. I think that's okay. But today I will do it in a talk format. So I have taken all the samples and I will walk you through and describe what closures are all about and what's excitingly new in Rust 2021. So for that, I have taken a sample project and I've created some snippets because in 45 minutes I cannot write so much code. And those who have seen my talks before, I frequently use snippets so that I can bring in more content without you watching me mistyping. So I've prepared snippets. Is this one. Okay, and let's run this guy. Let's run a cargo watch down here so you always see the result, what's going on. I think I can move that one here up, and I think we are good with that. So let me quickly zoom in a little bit and show you. Oops, first we will do the following. So good. So let me quickly introduce you to closures in Rust. That's the 101 of closures. If you are not that experienced with Rust, this is what a Rust closure looks all about. You might be familiar with terms like lambda expressions or lambda functions or arrow functions in JavaScript, and this is the syntax of such lambda functions or arrow functions in Rust. They are not arrow functions, as you can see, because you use the pipe symbol to specify the parameters, and then you specify the body of the closure just as you can see it here. I was told that this may be similar to how it is done in Ruby. I've never written any line of code in Ruby. If you are a Ruby developer, let me know in the comments section. I would be interested. But for me, coming from a C#, TypeScript, and JavaScript background, that syntax was a little bit new. So let's take a look at the code here. We take a variable x, and we have a getAnswer variable here, and this variable is essentially a closure, because when you take a close look, you will see that this function, this one, captures the variable x from the environment. So the environment has the variable x, it is captured inside of this closure, and at the end, we get the result 42 because we call the method, as you can see it here, with the parameter 21. So that's nothing special. That is how a closure works, and in the next half hour, we will dive a little deeper into how this stuff really looks like. So let's take a look at the next one here. So, okay, this one is empty, that's by design, and let's put it on here. Let's do a bunch of demos about syntax. Let's first focus on the syntax. Please take a look at line 5 and 6. These are the first two lines where I would ask you to take a look at. In line 5, we define a regular function, which is the add function, nothing special here. And in line 6, we assign the add function to a variable f. And what you already see from the Rust analyzer, that f is getting the type fn add i32, i32, like 32. So we see this small letter fn here, which is essentially a function pointer. This is technically not a closure. It's not capturing an environment variable. So this is just a function pointer. This is not already a closure. You can use this one whenever you need a function to f. And what you already see from the Rust analyzer, that f things are. Let's do a bunch of demos about syntax. Let's first focus on the syntax. Please take a look at line 5 and 6. These are the first two lines where I would ask you to take a look at. In line 5, we define a regular function, which is the add function, nothing special here. And in line 6, we assign the add function to a variable f. And what you already see from the Rust analyzer, that f is getting the type fn add i32, i32, i32. So we see this small letter fn here, which is essentially a function pointer. This is technically not a closure. It's not capturing an environment variable. So this is just a function pointer. This is not already a closure. You can use this one whenever you need a function pointer. And of course, you can use this function pointer to call the method. You see it here. Very simple, and you get back the result, and it works perfectly fine. Now, the idea of the closure syntax, we can try that one here, goes in that direction that let me zoom in a little bit, that we essentially remove the fn and the name. We don't need to come up with our own name. Instead, we take the variables, as you can see it here, and we move them between these two pipe symbols. The rest is essentially the same. The return type is inferred automatically from the return expression. Everything else works as expected. But we can simplify this in Rust even more. We can do something like this. If you take a look, if this is just a single line expression, we can remove the curly braces to make the syntax look even nicer. Rust is smart, especially when it comes to type inference, so we can make this one even smaller. As you can see it here, I removed the I32 and I32 here. This is inferred, this type, by the Rust analyzer. This is not part of the source code, and still it works. Why does it work? Because the Rust compiler takes a look at the call to f, and it infers the types for x and y from the call to the function f. This is still a function pointer, lowercase letter fn, but this time I use type inference to let the Rust compiler come up with the correct type. The last example that I would like to show you here is not the best coding style in Rust. It's not considered to be good coding style. We'll get a Clippy error, but still it works. So I decided to let it in and to show you how this is done. What you can do is you can define an inline closure, as you can see it here, same closure as before, and you can immediately call this closure directly here after the declaration of the function. So this is possible. It works fine, but Clippy complains. So Clippy says, hey, assign this closure to a variable, and then you can call it similar to up here, where it works closure as decided to let it in and to show you how this is done. What you can do is you can define an inline closure, as you can see it here, same closure as before, and you can immediately call this closure directly here after the declaration of the function. So this is possible. It works fine, but Clippy complains. So Clippy says, hey, assign this closure to a variable, and then you can call it similar to up here, where I assign the closure, the function pointer, to a variable, and I call it down here. So this is considered not the best coding style, but still it works. Now you've seen it. Okay, maybe it was a little bit interesting. Good. So this is the basic syntax of closures in Rust. That was 101. We have to dive a little bit deeper. Let's do that. Let's take a look at this example. This example defines, as you can see it here, a function add. I will zoom in a little bit so you will see it again. This defines a function add as we've seen it before. But the big difference to the very simple samples that we saw before is that we are now doing a little bit of functional programming. So I define a second function. Let's use a different color here. And I would like to draw your attention to the third parameter. The strategy for calculating the result this time in this function is not hard-coded. This function gets two parameters, x and y, and the strategy for calculating the result is passed into calc_print using a function pointer. So please note the lowercase fn here. This indicates a function pointer, which will receive an I32 and a second I32 as a parameter, and it will result in an I32. So therefore, we can, and let's go back to red again, we can pass in the add function, which we have defined up here, and it works perfectly fine because this is compatible with the definition of the calculator parameter. We can also use a closure, although calculator is not a closure type, which we will learn about in a second. In this case, it's a function pointer, but this is perfectly fine, as long as the closure does not capture any environment variables, any variables declared outside of this, although calculator is not a closure type, which we will learn about in a second. In this case, it's a function pointer, but this is perfectly fine, as long as the closure does not capture any environment variables, any variables declared outside of the closure, everything is okay. So this one is, we've seen before. This I32 and I32, the types are inferred here, so I do not need to specify them manually. Works as expected if we've seen before. This I32 and I32, the types are inferred here, so I do not need to specify them manually. Works as expected is now the calculator without a function outside of the closure, everything is okay. So this one is now the calculator without a function definition. It's an inline function and specified as expected. As we've seen now, we will learn about in a second. In this case, it's a function pointer, but this is perfectly fine, as long as the closure does not capture any environment variables, any without a function definition. It's an inline function and specified as expected, as we've seen before. This I32 and I32, the types are inferred here, so I do not need to specify them manually. Works as expected. If I run this, I will get the result 3 and 3 two times, because add and this closure, they do essentially the same. So this is a function pointer, and now you've learned that you can use closures wherever you want to have a function pointer. But when you really have a closure that captures a variable that is declared outside of the function, of the closure function, then this fn does not work anymore. So if I go here and try to do something like this, I get an error, and this error is by design. Let me show you what's going on here. I have defined another variable, which is called z, and I have used this variable c inside of my closure. So I'm now capturing this. I will get the result. both 3 and 3 two times because add and disclosure, they do essentially the same. So this is a function pointer, and now you've learned that you can use closures wherever you want to have a function pointer. But when you really have a closure that captures a variable that is declared outside of the function, of the closure function, then this fn does not work anymore. So if I go here and try to do something like this, I get an error, and this error is by design. Let me show you what's going on here. I have defined another variable which is called z, and I have used this variable c inside of my closure. So I'm now capturing a variable from my environment, and this is no longer a function pointer. In fact, if we think about how this can work, it is super important that this does not work, because this expression, this closure, cannot be represented by a simple pointer to a function. We have a function which needs access to external state. In this case, it needs access to the c variable, and therefore we need a different data structure. Just a function pointer is not enough anymore, so this does not work. We have to think about how we can solve this problem, and we have to think about how we can make this work with a different type than just the small letter fn here. So let's remove that one and go into the next demo. This demo looks very, very similar to what you have seen before. Let me zoom in to make sure that everybody can read it properly. This time, if you take a close look at the code, I'm not using the lowercase fn anymore, but I'm using the fn trait with the uppercase f here. The uppercase f is, as I said, the fn is here a trait. Therefore, I need a dynamic dispatching. I need a trait object, which I have to put on the heap in order to make it work. So why is that important? Well, think about it. Here, this works as expected. We only have to put the function pointer in a box, and then we can pass in a regular function pointer. Check, works as expected. If we have a regular function, as you can see it here, a regular closure, which does not capture any environment variable, everything is okay. We only have to be explicit in putting it onto the heap in a box, because that is how Rust works. Rust is very explicit. There is no magic happening by convention. You always have to type what you really want to do, and therefore we have to put the closure into a box in order to be able to pass it to our calculate and print function. The interesting thing comes down here, because this time we can take this closure, which captures the c variable, put it in a box, and it works perfectly fine, because now we have a trait object. What's technically happening behind the scenes, at least conceptually, not technically at the very low level, but conceptually, what's going to happen is the following. Let me show you that one. What's going to happen is we are going to get a kind of, as I said, conceptually, we are going to get a structure where we store the captured variable, as you can see it here, and the structure also holds, as you can see it here, the logic of the closure. We will, at the end of the day, we will get a structure, and here you see it, and we will pass in a trait object, which represents, as you can see it here, the structure consisting of the captured state plus the method which operates on the state and, of course, the parameters. So conceptually, behind the scenes, you always have to think, when you talk about closures with the uppercase F, that behind the scenes you get kind of a structure with data, state, and functionality. This is also the reason why sometimes, let me go back one element here, that sometimes you have to specify, oh my god, a lifetime for a closure. Because in this case, Rust needs us to specify a lifetime, because it is important that the lifetime of the variable fits to the lifetime of the function. That's essentially the structure behind the scenes. In this case, we don't have to write the lifetime manually. We can use lifetime elision here, because Rust will come up with the correct lifetime, but it would not work if you do not specify this one here. If you try to do that, we will get an error, and you can dive into the error later if you are interested in why we have to specify lifetime here. I only today have 45 minutes, so I will not go into the details, but at least a little bit it should become clear when you remember that having a closure is essentially another form of writing conceptually a structure. Okay, and there we already know that sometimes or often we need lifetimes. Okay, that is the uppercase fn. Unfortunately, the story doesn't stop here, because this uppercase fn is just one trait for closures out of 3. In total, we have 3 types representing closures in Rust. Fn is the first one. The fn, the uppercase fn trait, means that we are not mutating the captured variables. We can mutate the captured variables if we use the trait fn mute instead of fn, and this is my next demo. This example is split into 2 parts, and I will zoom in and I will walk you through the code. First, draw your attention, please. Let me draw your attention on these 3 lines. As you can see, this calc result closure calculates x plus y, but the result is not returned, but the result is written into a captured variable. So in this case, I'm mutating result. So therefore, this is not just a closure, it is a mutating closure. It is an fn mute. We don't see that if we just use these 3 lines 5, 6, and 7. Because here you see, I'm just calling it result, everything is fine, everything is good. But it becomes very clear if we take a look. Oh, that's maybe a little bit too wide. Let me do it like that and zoom in again. If we try, again, to store this closure in a variable and write the correct type, we will see that we can no longer use the fn trait here. We have to use the fn mute trait. Because only with that, we have a mutable borrow of the captured variables. I can show you that if I remove the mute here, I will get an error here. This does not work, as you can see it here, because the captured variable is an fn closure, and therefore we cannot assign a value to the variable result. What we have to do is we have to change that to an fn mute, as you can see it here, to get a mutable borrow inside of the closure. And then everything works as expected. Let's make it here. We put it in a box as we did it before, and then we can call the result calculator, and everything is okay. We can drop the result calculator, that's fine here, and then we can print the result. That's perfectly okay. That was an fn mute. So let's quickly recap. Fn for capturing variables with just a borrow, read-only, immutable borrow. Fn mute for capturing variables for mutation. So the third one, I told you that there are 3, is fn once. Fn once means that we are moving ownership into the closure. Let's take a look at these 2 examples. I think they should fit on the screen quite nicely. Yes, let's take a look at the first one. I would like to draw your attention to the first 4 lines of code. As you can see, I define a vector with some numbers, and then I get an iterator into numbers iter. Then I would like to do the sum over this iterator, and in order to do that, I have to move the ownership into the closure. I can use the keyword move to essentially move all the captured variables into the closure. Now the closure is the owner of this iterator. And with that, I can call the fn once here, and I will get a result. In this case, the sum of the numbers 1, 2, 3, 4, 1, 2, 3, 5, 6. Okay? I've got the 4. I don't know why. It becomes even clearer if we take a look at the second part. Let's use a different color here, this one. Because in this case, I'm storing the closure in a typed variable. And the important type here is this one, as you can see it here. This uses the fn once trait. And the fn once trait is okay because we are again using the move keyword here. We are moving the numbers iterator, the ownership, into the closure, and therefore the result will be an fn once. We can only call it once. We can only call it once. Okay? So we have fn for immutable borrow, fn mute for mutable borrow, fn once for taking ownership. You might ask yourself, why do we need that? Why is this move so important, and why does Rainer tell us about it? Well, one of the most prominent use cases of fn once with the move keyword, is working with multiple threads. Let me show you a quick example. In this example, please note that we have a counter and a counter string outside in the main method. Then we spawn a thread, as you can see it here, and we are using the move keyword to create an fn once. We are capturing the variables by taking ownership. As you can see here, I'm just incrementing the counter. If the string is not empty, I'm adding a comma here, and then I push to the string the counter value, and after 5 elements, I'm breaking, and we are waiting a little bit. So at the end, I'm joining, so I'm waiting for the thread to continue, and if we try to run this one, the counter string here, it doesn't work. The counter string was defined here in the main method, so you might think that we still have ownership here in the main method, but we don't. Because of the move keyword here, we moved ownership of the variables into the thread. And that's important, because we explicitly want to give ownership to the thread, and we do not want to have a chance to for instance, access these values by design in the main method. That might result in some kinds of race conditions or similar bad things, and therefore the move keyword is super important here. We are moving the captured variables, the ownership of the captured variables into the closure here. Okay, so this is an fn once, an application that you see pretty frequently when you do multi-threaded programming. Okay. Good. That the move keyword is working with multiple threads. Let me show you a quick example. In this example, please note that we have a counter and a counter string outside in the main method. Then we spawn a thread, as you can see it here, and we are using the move keyword to create an fn once. We are capturing the variables by taking ownership. As you can see here, I'm just incrementing the counter. If the string is not empty, I'm adding a comma here, and then I push to the string the counter value, and after 5 elements, I'm breaking, and we are waiting a little bit. So at the end, I'm joining, so I'm waiting for the thread to continue, and if we try to run this one, the counter string here, it doesn't work. The counter string was defined here in the main method, so you might think that we still have ownership here in the main method, but we don't. Because of the move keyword here, we moved ownership of the variables into the thread. And that's important, because we explicitly want to give ownership to the thread, and we do not want to have a chance to for instance, access these values by design in the main method. That might result in some kinds of race conditions or similar bad things, and therefore the move keyword is super important here. We are moving the captured variables, the ownership of the captured variables into the closure here. Okay, so this is an fn once, an application that you see pretty frequently when you do multi-threaded programming. Okay. Good. Now let's think about what has changed in Rust 2021. Now you have the basics. You've learned about function pointers. You've learned about the fn trait that you frequently see when you take a look at what's new in Rust 2021. Let me quickly describe it. Let me walk you through this code, okay? The constructor assigns foo and bar to anything and anything else. The important thing comes here. We create something, and when we explicitly drop a member of something, anything, we drop only one member. The other member is still okay. And if you now take a look at the closure down here, you will see that we are capturing something.anything else. We do not capture something.anything, as you can see it here, but we capture the other member of the structure. And up to Rust 2018, this was not possible, because in this case, Rust would capture the entire object, the entire instance of the structure. So therefore, we cannot access st.anything else, and we get an error. Yeah? Use of partially moved value st. This is exactly what Rust 2018 gives you. Now, if we take a look here and switch that one to 2021, let's wait a second until it is continued. We see already in the output down here that now we get a result. So if we take a look here at the main method, oh sorry, I still have this Clippy error, but for demo purposes, it's perfectly fine. Call it here. The point of this demo is that I no longer get an error. We still capture st.anything else. It is perfectly fine to access anything else because we have only dropped anything and not anything else. So the capturing is no longer done on the structure level, but it's done on the member level. And this is called disjoint capturing inside of closures. Disjoint because we only capture one element and not the entire structure of the structure to a local. You can force Rust to move everything in it if by just assigning the entire instance of the structure to a local variable inside of the closure, and then you can enforce the behavior that everything is captured. But by design, this is a breaking change. By design, it only captures the member of the structure. Now you might ask yourself, why do I need that? Where is the advantage? Where is the use case? And I tried to come up with a simple, a little bit funny and entertaining example that should bring everything to the point. I don't know about you, but when I was a child, I frequently heard the Cinderella, the tale of Cinderella, Aschenputtel. You maybe know it from German. If you have taken a look at the Cinderella movie from Disney, you might not know how it really worked in the original book. There, Cinderella, when the bad sisters threw out the lentils on the floor, then Cinderella had to go through all these
The storage bucket is public. That is not a mistake. That is a growth hacking funnel. Every year we get the storage bucket is public. That is not a mistake. That is a growth hacking funnel. Every year we get personal thank you letter from cloud provider for hitting Q1 revenue target. Their Q1 revenue target. Yes, let's talk about the cloud. Kubernetes gave us portability. We can now move the outage from AWS to GCP within minutes. Our cloud bills, they send it in scientific notation. Back in the days, you needed 2 of everything. Now you need 20. I always said power to the microservices. Now we have more programming languages than developers. I write all diagrams on paper because everything looks good on paper. Hello World in the cloud involves 1 load balancer, 2 database, 3 web servers, and 2 different cloud geozones for the observability stack. Are you asking about service? Oh, mamma mia, this is a long, complicated I don't really understand how it works. Our coffee machine runs on the cloud. I know it does not work. I like to say until cloud bill arrives, liquidity is like Schrödinger's cat. We are now doing edge computing. We moved our server rack 20 meters closer to AWS in data center, even a less latency. Oh, that is SLA in the cloud meal. Observability this, observability that. The app stores more data about uptime than data about the app. Log ingress costs more than whole service. You're underestimating my underestimation. Crash loop backoff is feature discovery. When I see over 3 GB Docker, I know it is node modules. The cloud is elastic. We set alerts for 100% memory or killed. But AWS memory goes to 110%. Nothing is owned in cloud. Everything is shared, including noisy neighbors. When you cannot SSH it to master, you are the slave. We automated our DBAs with managed service. No, we are paying more, but less complaining. Role-based access control. Kubernetes saved us so much money. We can almost afford the team that runs it. Why this new Lambda can't assume IAM role? High availability is 99.99%. Other 0.001 is the keynote demo. What does core mean in Kubernetes? Nobody knows. Normal CPU go to 100%. Cloud CPU go to 110%. Different physics. My favorite AWS tool? rsync. I do optimization all the time. I mark 3 orphan ABS volumes and tag them as research. My tagging game is immaculate. We wrote a Lambda function to shut down other idle Lambda functions. It is now the biggest cost center. Half the Grafana dashboards are services that don't exist anymore. Our roadmap is Gartner Hype Cycle. We also have the private cloud, yes, whatever private means. I have 35.5 years in the industry experience with on-prem and hybrid cloud, microservices, serverless, back to monolith, hyperscaler, back to single on-prem server running per script. We are thinking about going back on-prem. I will just finish the DevOps article I'm reading. It is an interview with all 7 customers of Azure. Oh, it is pager alert. We have team for this. No rush. It will take 2 minutes for VPN login anyway. It works more deterministic than MySQL on cloud. Nothing is normal in the cloud. Do you know how many ENIs per EC2 instance? Listen, nothing is standard in cloud. Try importing MySQL local database to cloud database. You will hire all team and fix cloud bugs for a cloud provider. Cloud was so expensive, I could write my own telemetry system. How do I estimate the cloud bill? This complicated mathematical function of using the we're still liquid. I have whole degree in guesstimates. CloudFormation and Cognito are both AWS. And incognito are both AWS. The completely different usability. My tip for more performant cloud, ask for more replicas. We like to take the smartest minds of the generation and then have them VPN tunnel debugging. I know what I'm doing.
Async Rust is a bad language, but to get at whatever the hell I mean by that, we need to talk about why async Rust exists in the first place. Let's talk about it. Okay, this is great. I love this. I already love this. Starting off the conversation, giving us the proper context. Let's go. Modern concurrency. They're green, they're mean, and they ate my machine. I don't get it. And that guy's face doesn't look like he wants to be here either. Suppose we want our code to go fast. We have two big problems to solve. We want to use the whole computer. Code runs on CPUs, and in 2023, even my phone has 8 of the damn things. I got a new phone, by the way. Look at this sweet Pixel 7. It's pretty neat. I no longer have a bright line down the middle of my phone. Pretty cool, huh? If I want to use more than 12% of my machine, I need several cores. This is true. Even in some of my best attempts, I still can't get Node to use 100% of the CPU. I've tried so hard to make it just use as CPU, and I cannot make it. We want to keep working while we wait for slow things to complete instead of just twiddling our thumbs. Sending a message over the internet or even opening a file takes an eternities in computer time. We could literally do millions of other things meanwhile. Very fair. And so on. We turn our friends parallelism and concurrency. It's the favorite hobby of CS nerds to quibble over distinctions between the two. So to oversimplify, parallelism is about running code in parallel on several CPUs. Concurrency is about breaking a problem into separate independent parts. I'll give my take on it, which is parallelism is having machine instructions executed simultaneously. Concurrency is having tasks that do not need CPU to move out of the way and allow other tasks to run while it's waiting for a result. Concurrent my nuts out your mouth. Okay, I don't know how I got that one, but that's about fair. Is that about a fair-ish statement? Wrong again. Parallelism is more than one thing happening at once, whereas concurrency is stacking them like bricks. Parallelism is a subset of concurrency. I don't believe that. Parallel is at the exact same time, current at the same time interval. Okay, that somehow makes it less clear. Now I think everybody's more confused at this point. I'm still confused. What's the difference? Okay, think of Node.js. When you do think of this right here. Here we go. This guy, this code. Okay, not that code. Vim test this right here, right? 1 is going to take 1 second. 2 is going to take 2 seconds. We can either run them one at a time. This is not concurrent or parallel, or run them both at the same time. But here's the deal. 1 will run until it relieves any need of the CPU. Then 2 will run and relieve any need of the CPU. And then 1 will pick back up after its 1 second wait and then start running and then be done. And then 2 will pick up after 2 seconds and pick it up. This will take a grand total of 2 seconds. It's concurrent, but it's not parallel. 1 is not executing at the same time 2 is. That's concurrency. Concurrent processes overlap. Parallel runs literally the same time. That's why I was specific. There's at least 2 lines of running machine code. Like something is happening. 2 different, because you can have parallelism and they're not running the same code. They don't have. I don't think there's any requirement that it has to be identical code being ran. They could be running different parts. Chipboard politics, yeah. Okay, whatever. I think we all get it. We're moving on. These are not the same thing. Single core machines have been running code concurrently for a half century now, but they are related. So much online, actually ignore. Dude, we literally just did this. We're doing this, okay, right now. Ignores how often we break programs into concurrent pieces so that those pieces can run in parallel and interleave in ways keep our cores crunching. We didn't care about performance. Why would we bother? So let's see. How do I concurrency? One of the simplest ways to build a concurrent system is to split the code into multiple processes. After all, the operating system is lean, mean, concurrency machine, conspiring with your hardware to make each process think it has its whole box to itself. The OS scheduler gives us parallelism for free, running time slices of any process that's ready on an available CPU core. Once upon a time, this was the way, and we still employ it today whenever we pipe shell commands together. Let's talk about Gulp build tool. Oh no. A lot of you JavaScripters are discovering that it is a lot more efficient to pass data from task to task rather than writing it to disk between each step. Or Akka actors in Scala. Concurrency sure is simpler with non-shared memory and immutable messages, huh? Okay, let's begin with process and pipes. They've been in Unix for 40 goddamn years. This is actually really funny, by the way. This is really good. It's been happening forever. But this approach has limitations. Inter-process communication is not cheap, since most implementations copy data to OS memory and back. Yep. Mutex-based concurrency considered harmful, or Hoare was right. Some people, when confronted with a problem, think, I know, I'll use threads. And then they have two. This is such a good statement. This is a beautiful statement, right? This is a beautiful statement, okay? This is parallelism getting awful. We can avoid these overheads using threads, processes that share the same memory. Common wisdom teaches us to connect them with mysterious beasts like mutexes and conditional variables and semaphores. Isn't a semaphore just a mutex with a wider lane? It just has a higher count to begin with. Anyways, yeah, I know. I'm just saying that just so, okay. Anyways, this is a dangerous game. So, I mean, I like using this. I have my little test clients all use this. I think it's a lot of fun to use semaphores to produce asynchronous code. It's fun. I mean, I actually enjoy it. A little Tokyo spawn, a little semaphore, a little glass of wine, and you got yourself a segfault. This is a dangerous game. Simple mistakes will plague you with the race conditions and deadlocks and other terrible diseases that fill your code with bugs. But only on Tuesdays when it's raining and the temperature is in the middle of 3. Modern hard. Here we go. Threads enjoy process languages that make it hard to accidentally scramble another thread. Yeah, Rust. Each thread has very obvious we're just gonna do a quick, I'll read here in 1 second. I just want to go over this because it's Nate. If you guys don't know who Nate is a boss, okay? Nate's a boss, okay? He's my favorite anime character. I don't know if you know this, but I'm pretty sure... oh, hey, wait a second. Oh, no. I just realized that my Vim plugin's broken. No! There you go, Nate, all right? My favorite anime character, Nate. I've always appreciated him. Commonly referred to as N9. You may have heard of him. All right. How to get into software. I end up talking to a lot of people about how to get into software development. Is it weird that I have a picture of him on my computer? Is that strange? Should I be worried about that? So I'm creating this guide. This guide is by no means comprehensive and is light on specifics. This is by design, as the vast majority of learning you will need it to do is self-directed for your career. Okay, this is interesting. Additionally, this guide is much more focused on back-end development, though you'll be exposed to both back and front-end. Okay. Number 1, install Arch Linux on your main computer. All right, people, we're going for single, okay? We're going for broke. Let's see where we're going. I'm loving this, all right? And use it for all computer tasks. Let's go. Let's go, Nate. I picked Arch not because it is the most perfect or the best, but because it requires you to see what's going on in your computing environment. Okay, so this actually is a good argument if you have the time. This is a good argument. This is to see what your computer does at a little lower level and to see how a more modular computing environment works. You will learn how to use the command line and likely get some experience writing shell scripts to tailor your personal computing to your own preferences. Additionally, whether or not you end up sticking with Arch or Linux at all, you'll find the Arch Wiki to be a useful reference for debugging software products. Okay, super tough one take. Like, take one, hot AF. Read Automate the Boring Stuff. This is a free Python book that let's see, you'll learn the basics of, and not only this, I've how'd out for ocean of just habit scripts. Let's see. Your 3 choices are NeoVim, my choice, Emacs if you want to learn another programming language, and VS Code. This one is that is most used in professional circles. At the end of the day, your work and play as a software developer is 90% editing text files, and you should be extremely effective at editing text files. This should be more personal to you than your computer, as you will find your productivity is directly tied to your abilities in the text editor. I 100% agree with this. I can do so many things fast because I know my editor really, really well. This is a very great thing to keep in mind. You should at least learn your tools the best you can. If you don't know your tools, you will always be in this weird spot where you're kind of flailing around a little bit. I just think this is great. So yeah, slide into the author's DMs. Absolutely. And I like that he said you can really, like, here's 3 good options. He doesn't say Helix. You can't really customize Helix as much. It's a good way to put it. Create a profile on GitHub and learn the basics of version-controlled Git. 100%. This is great. Okay, so actually this advice, I thought it was going to be a pure meme right here, but it's turned actually really good. This is really good. Let's see, from here on out, you will put all your code and things in your GitHub, so potentially employers will see that you are productive. Git is a difficult program to understand and work with, and much of it will not make sense. Use it regularly and practice in reading up, and you'll eventually grow to understand enough to use it in a collaborative environment. A good resource. Actually, a very good point, which is the first time you use version control, it does seem a little confusing, right? First time I used it, I was a little kind of like, what the hell's going on? But then once you start using it, it becomes easy. Okay. Learn Markdown. Great advice. I use Mario. Let's see. Use it to write documentation notes and pretty much anything that have been written on. Yep. This is useful because it's a common format in software circles that can be rendered in another program more or less. Yeah. This will be a main way of writing documentations. This is good advice. This is actually, no one ever just says learn Markdown. These are come and go log terminology. Being a terminal, then you put them on a server. DigitalOcean is that are using it. I've said this a bajillion times. Generally current here. There are plenty of other programming languages that are out there equally good choices, but I think this is a good place to go from Python. I might recommend Node as a second language. Node is actually a runtime. JavaScript would be the second language. If you really enjoy writing websites and really don't care much for the Python stuff, I don't have a reference for Node like I do for Go, so you'll be on your own for finding a good book. Functional programming and write a program. Interesting. I don't even independently with this. I just never want to write functional programming. I do some of these problems. Like 20 will be enough to see a common ways people write performant code and will expose you to many of the common algorithms that will be included in programming interviews. A lot of people overdo them and never end up getting practical programming knowledge, so you'll want to avoid becoming a career lead coder. Again, just base advice. I mean, personally, I throw in there, take the Primogen's free course on algorithms and data structures because algorithms and data structures are more useful in the interview than lead code problems, okay? Additional musings. You need to write a program or make a website. The number of instructions above are not enough to get the job. You'll need to have some examples of code you've written along with the experience of having written some code. Coming up with programs or websites to write is difficult. The only way I've been able to reliably do this is examining what happens in my own computing experience and finding things that annoy me. I love this. So that's my big motivation, is always solving things that annoy me. One of my favorite problems to solve is changing my experience, but you get experience writing programs. Advice. Not everything I hear the most. How about neither? Build something. Build anything. Can you complete it? Try to get composed to just grandiose thing. What will you do? You'll end up probably getting defeated. You'll probably end up not finishing, and then you'll have nothing to show for it. Whereas if you at least do something, even if it's small, you've had the full experience from building something that has only an idea to the point where it's considered completed. That's why also I don't change Harpoon. Harpoon for me is completed. Experience from doing it, and that is important, web specific. But the best way to learn what you like is just to make shit. Just make list is ongoing. Now that's great. Go back and forth between those and notice where my cursor's at. Do you see something about my cursor? Where's my cursor at? Same place as it was when I left it. Harpoon. Harpoon's really cool. I love Harpoon. It's my best plugin I've ever written, and it only has one thing, and I honestly, I've been not allowing changes to go in because I'm very afraid that people are gonna, I don't want it to change, right? Har-based, yeah. Like, I like it. I don't want more integration. The only thing I want to do is think about like an inventing system for people to write their own plugins. These are things where, let's see, yeah, where is how you get paid well. People, you don't, like, here's the deal. If all you ever do is just incorporate Tailwind, incorporate React, go serverless, build a small application, and that's what you do, there is a limit to that pay, because that is not necessarily a complicated task. It's just not what you do. There is a limit, incorporate React, go serverless, build a small application, and that's what you do. There is a limit. Just say you go really far into one of those aspects, all right? Whatever it is, and you become a master of that domain. You will be able to be hired for that one task because you are the best at it or one of the best at it. Niching is really important. And it doesn't have to be super tight, right? It doesn't have to be like, I am the best, niche is to look at a problem, see what tools could be made, and try to guess what is the best tool to make. That's it. It's not and if you can be super niche, you can get paid a lot. Honestly, I'm really, really good at not knowing what to do. You're the dad I've never really had. Oh, thanks, son. Yeah, I would say that that's actually not a bad idea. That is not a problem. Found your way to this post and you want some help, feel free to reach out to me. Oh, you want to be reached out?
I spent hundreds of hours preparing for my cloud certifications, and when I passed, I still couldn't land a single job. But I didn't give up and went to the next interview with another certification under my belt, thinking that that would be my golden ticket, but nothing seemed to work. Then I discovered the 3 simple principles that took me from having no job offers to having so many opportunities that I have to decline 92% of them. Hi, I'm Suleiman, and I make over $50,000 a month running my own cloud security consultancy. And with a decade of experience in this field, I've uncovered a truth that might surprise you. While everyone is chasing for the next cloud certification, top companies are quietly shifting their focus. They're looking for something else, something that no certification can teach you. I discovered exactly what they need, and I use it to land 6-figure cloud jobs, not just for me, but for so many of my students as well. So today, I will reveal the 3 principles that you can use to get the dream job you've always wanted, make more money than you thought was possible, and achieve the work-life balance that you've always dreamed of. If you're new to the cloud, click the link in the description of this video for my free cloud engineering guide. It'll take you from a complete beginner to understanding the core concepts that every cloud professional needs to know. Now, let me tell you a big secret that a lot of people don't want you to know. Certifications are not just overrated, but they are worthless. I remember the day that I passed my AWS exam. It was a professional level certification, and honestly, I felt great. I thought, okay, this is going to open so many new doors for me. Straight away, I jumped onto LinkedIn, updated my profile, and thought the job offers are just going to find their way to me now. It was like an expectation of success. I kind of felt entitled to a 6-figure cloud job now. At this point, I actually had 4 AWS certifications, so I'm thinking that I'm as qualified now. It was like an expectation of success. I kind of felt entitled to a 6-figure cloud job now. At this point, I actually had 4 AWS certifications. So I'm thinking that I'm as qualified as they said, looking for someone for these exams. And for what? I realized that the cloud job market was even more competitive than I originally thought. Yes, the market is booming. The cloud market is projected to be 1.6 skills that go way beyond what any certification can teach you. You can't just show up to your interviews with your cloud certifications, especially if you have no experience in the perspective that other end. And it's the same reason you consultancy. You see on the job performance. Being book smart won't that really on general six-figure cloud role, I needed to niche down and specialize in one area. That because there just aren't will pay you. Who would you rather take it to? A general mechanic who works on all cars or a specialist who only works on Ferraris? You'd pick the Ferrari. A Ferrari can handle in companies, breaches, cyber attacks. Just look at Wright and Sneak, who have kindly sponsored this video first line 7. And here is find your move on. It's that simple. Plus, Sneak integrates seamlessly with the services you're already using on AWS, like Jira, AWS Code Pipeline, IDEs, and more. So you don't have to learn a new app to stay secure. It's a tool that I wished I had when I was starting out, and it's something that I use frequently now in my cloud security work for all of my clients. You can try out Sneak for free forever at sneak.co/Sulaiman, and trust me, it's a game changer for anyone who's serious about cloud security. Thanks Sneak for sponsoring the video. Now, back to my journey. So what did I do? I'd come home from my 9-to-5 job and I would spend a few hours every single day diving into cloud security. I was building secure environments, learning about encryption, identity management, you name it. All of this at the same time as building this YouTube channel and trying to have a social life too. Was it easy? You name it. All of this at the same time as building this YouTube channel and trying to have a social life too. Was it easy? On to the second thing, building your portfolio. So, engineer is on you there. When I'm hires that you've solved, don't tell me you know about Docker and infrastructure as code. Show me how you've applied it over this application that you've another that scales to list the AWS associates traffic. Showcase your portfolio. Solve killer cloud portfolio deployed on AWS using services like EC2, S3, DynamoDB, a CI/CD pipeline using AWS to code and pipeline, infrastructure as code templates using Terra. For you is that you know it was a small when I was feet and solve business problems. Cost on product because if you text it, it does. I know. For some, you need to land a SaaS show for you. Why? Because I really good ones come through the application. It was because I had been consistently sharing my projects and insights on LinkedIn, and a former colleague saw my post and recommended me for a position at his new company. Networking isn't about being people in your industry. It's about giving value before you are my class dealing with that company. No, that found in what else I teach in things. It sounds like you're being proud. I needed to focus. I was honest and real. And you know what? And the solutions that I found. It wasn't always groundbreaking stuff, but it was honest and real. And you know what? People responded to that. And the way you take that to the nothing this YouTube channel opportunity princess is one of the reasons why I got an over in front of time or buy some brand post for a month. Much prioritizing what's really important. For me, that was sacrificing some short-term comfort